And we have the third question. If you missed the second question, please quickly check that and watch the first question, second question. So this is the third one. We have the y, the x equal to what? E2x cos y or all square. Okay, if you check, this one is what? This one is f of x, and this one is what? G of what? G of y. So separate the variable. Okay, so we have to remove this one from here. Remove this one from here, the g of y. Okay, and that will be equal to what? 1 over cos y or square dy. And then this one also remove it from here by multiplying both sides by dx. Okay, and that will be equal to what? That will be equal to e2x dx. Okay, then integrate both sides. This will become, this fraction here will become 1 cos, this one will be cos squared y dy equal to e2x dx. And don't forget that 1 over cos is what? Is sec. 1 over cos x is what? Sec x. So this will become integral of what? Integral of sec square y. Okay, dy equal to what? Integral of what? E2x dx. The integral of sec square x, no, sec square y, integral of sec square y, sec square y, integral of sec square y will give you tan what? Tan y equal to this one. For exponential, integral of exponential, it will give you the original function, but you must divide by the what? By the derivative of the exponent. The derivative of 2x is what? Is 2. So you divide by that derivative. Okay, then plus what? Plus c. So that is done. So the next thing to do now is to use the boundary condition, which is what? This equal to what? This. When next is 0, y is what? Y is 0. So act times 0 will give you 0. Then put here 2 times 0, that's 0. Substitute here 2 times 0, that's 0. So anything to the power 0 is 1. So 1 over 2 plus what? Plus c. So c is what? Minus 1 over 2. So that's finished the work. So the next thing to do is come back here. And that will be equal to what? Tan y equal to e2x over 2. Then minus what? Minus 1 over 2. So that's done. So if you want to do efficiency, we can just take the arctan of both sides so we can find the y. Take arctan of both sides, and that will give you, when you take arctan of tan of a tangent, that will give you y. So we have y here equal to arctan e2x all over 2 minus 1 over 2. So that finished the work, and that's that. If you are new on the channel and you are yet to subscribe, please do it right now. Okay, and also don't forget to click on the notification bell so that as we upload, you get notified. Okay, your comment constructively is highly appreciated. Okay, make comment constructively. Thank you for this. So, question 4: solve the differential equation. And we have this. Okay, this 5 here means 5 times this fraction. Okay, and don't forget that this numerator is f of y, and this denominator is what? Is f of x. Okay, so let's separate the variable. And before we separate the variable, this is what will tell you that this is what? Separable differential equation when you have f of x, f of y, x. Okay, it could be f of x. Separable differential equation could take the form of this. Okay, it could take the form of what? Like we have in this question. It could take this form. Okay, it can also take the form of what? F of x or what? Over g of y. So that will tell you you have to use separable techniques. Yeah, in addition to the question, we have this boundary condition. In addition to the question, we have this. Okay. Step 1. Step 1, remove this one from here. Remove this with the 5. And that will be equal to what? 1 over 5 into bracket y squared plus 1 dy. Because this 5 means times the numerator. Okay? So dy. Then this dx also, remove it also from that place. Multiply through by dx. And that will be equal to what? 1 over x squared minus 11x plus 24. Okay? dx. So with that now, I've separated the variable. Separate the variable and put the integral sign on both sides. Okay? Once you have separated the variable, then you introduce your integral sign to both variables. Then the next thing we do now, we know the right-hand side is a direct table. You can take this 1 over 5 outside. Take that 1 over 5, this 1 over 5 outside. Then you have this plus this equal to. This one is not a direct table. So we will need to do some algebra on this. Okay, that's not a direct table. So, and that will take us to, let's look at the denominator. Can we factorize the denominator? If we can factorize the denominator, then that will take us to partial fraction. So take this fraction, take this content of that integral, take it outside. Minus 11x plus 24. So, and that will be equal to what? 1 over. Yeah, 24 is what? Factors of 24 is, it could be 12 and 2, but 12 and 2 can never give us 11. Okay? Out of 8 and 3, 8 and 3 will give us minus 11. Minus 3 minus 8. Okay? Minus 3 minus 8. And when you multiply those two factors together, you get back your what? Your plus 24. So, put one x here, put 1 here, minus what? Minus 3 minus 8. Yeah, once we are able to factorize the denominator, then it will lead to partial fraction. So, and this will now become 1 over x minus 3, x minus 8 equal to a over one of the linear factor plus b over the second linear factor. So that's what we have. Then after that, we multiply through by the what? By the common factor, which is what? Which is x minus 3, x minus 8. Okay. There is a video on integration involving partial fraction. I'll put the link on the description so that you can watch. You can have a detailed illustration on how to solve integration involving partial fractions. Okay, so this is what we have now. If you do that, if you multiply 2 by this common factor, you have 1 equal to. This one times the common factor, that will be a into bracket what? X minus 8. Then this one also times the common factor, that will be into bracket what? X minus 3. Okay, then next thing to do now is try to destroy one and get another one. So we can say let x be equal to what? Be equal to 8. 8 minus 8, so that's 0. So a will go. So I have a equal to here 8 minus 5, that's 5b. So b is what? B is 1 over 5. I've gotten that. Then can we also destroy a here? Let's get the b. So let what? Let x be equal to 3. Let's x equal to 3, and that will be equal to what? 3 minus 5, that's what? That's minus 5 times a. Equal to what? Equal to 1. So a is what? A is minus 1 over 5. A is minus 1 over 5. Okay? So then we now have if you come back here, we have minus 1 over 5. The integral of this one is what? Is okay, let's write that. We have 1 over 5, 1 over s squared plus 1 dy equal to integral. We have expression for this, which is equal to what? My a is what? My a is My a is minus 1 over 5, minus 1 over 5, all over x minus 3, then plus. My b is what? My b is 1 over 5, 1 over 5, all over x minus 8. Okay, dx. Okay, so with that now, I will now have now, don't forget that integral of sum of functions will be integral of each of those functions. Okay, then we now have this one, integral of 1 over x squared plus 1 is arctan what? Arctan y, 1 over 5. This 1 over 5 can be outside the integration, that is minus 1 over 5. Integral of 1 over x minus 3, that's ln x minus 3. Then plus. Integral of this, that's 1 over 5 ln x minus 8. Then plus what? Plus c. So that finished the work. You just need to get the c. We have the boundary condition. Okay, when x is 9, y is 0. So substitute that into that equation. So if you do that, arctan 0 is 0, equal to 9 minus 3, that's what? Minus 1 over 5, ln what? 6, plus 1 over 5. 9 minus 8, that's ln 1, and that's equal to what? That's equal to 0. You cancel out, plus what? Plus 6. If you move this one to the other side, you have this. Then come back here and substitute. So we have 1 over 5 arctan y equal to minus 1 over 5 ln x minus 3 plus 1 over 5 ln x minus 8, then plus 1 over 5 ln 6. So 1 over 5 is there, 1 over 5 is there, 1 over 5 is there, 1 over 5 is there. Multiply through the equation by 5. By 5, so we have arctan what? Arctan 5, arctan y equal to I'm going to put the positive forward. This will be ln x minus 8, then plus ln 6, and then minus ln x minus 3. I just try to put the positive before the negative. So that's done. So we can stop there. The only thing we just need to do now is to just use the logarithm rules. Okay, we can stop there. Okay, so let's do the efficiency and get the y. So we now have arctan y equal to those one of plus the ln here. We can combine all the ln together. We have a common. We can combine all the ln together. So when you are adding logarithm, that will be multiplication of those functions, and that will be 6 times what? X minus 8 all over x minus 3. Everything under this. Okay, so what I did is that this one, you can combine this one to single logarithm. Okay, single ln. So those one of addition, that means the function will be multiplied together, and the one of minus, the function will be what? Division, as we have done there. Okay, so the final thing to do now is just to find y. Okay, and this is arctan, this is inverse function. So to negate this inverse function, what do? You take tan of both sides, and that will be what? That will be y. That will be y equal to what? Tan. To negate this inverse function, you take the tangent of both sides. If you take the tangent of both sides, this will be equal to y equal to what? Tan what? That will be equal to y. That will be equal to y tan what we have here, ln tan ln 6 into bracket x minus 8 all over x minus 3. So that's that on that question. That finished the question. So that's that.